This is the Honors Math 2 Unit 1 review. Number 1, we are adding two polynomials. When you add polynomials, you are combining like terms. Typically, you put it from highest to lowest power. So our highest power is y cubed. There's only one y cubed, so I'm going to write 4y cubed. And then y squared, I have a negative 17y squared and a positive 20y squared. Negative 17 plus 20 is positive 3y squared. Then I have a positive 3y and a negative 3y. When you add those together, you get 0. So we don't include those. I will cross them out. And lastly, we got the plus 16. So 4y cubed plus 3y squared plus 16 is our answer. Number 2. Again, we're adding two polynomials. Start with the highest power. There's only one a to the fourth, so that's 5a to the fourth. There's a negative 2a cubed and a positive 5a cubed. Negative 2 plus 5 is 3. There's a positive 4a squared and a negative 5a squared, so positive 4 plus negative 5 is negative 1a squared. We have a 5a and a plus 2. So 5a to the fourth plus 3a to the third minus a squared plus 5a plus 2 is our answer. Number 3, we're subtracting two polynomials. I encourage you to change each subtraction problem into an addition problem by distributing that negative 1 to the right hand side. So if I multiply everything in the parentheses on the right hand side by negative 1, I get a plus negative 6x cubed positive 5x and a plus negative 12. And then you add just like we did in number 1 and 2. So starting with the highest power, we have a 3x cubed plus a negative 6x cubed. That's a negative 3x to the third. No x squareds. We have a positive 12x plus 5x is 17x. And a negative 15 plus a negative 12 is negative 27. Number 4, again, we're subtracting two polynomials. Distribute that negative to the right side. So plus negative 6m to the third plus 8m squared plus 3m plus a negative 1. Starting with the highest power, we have a 4m to the fourth, a negative 3m to the third plus a negative 6m to the third. That's going to be negative 9m to the third. 6m squared plus 8m squared is 14m squared. 5m plus 3m is 8m. Negative 4 plus negative 1 is negative 5. Number 5, we are multiplying two binomials. And so we just got to carefully use the distributive property. 4x squared times 2x is 8x to the third power. 4x squared times negative 5 is negative 20x to the third power. 3 times 2x is positive 6x, and 3 times negative 5 is negative 15. There's no like terms. Oops, I made a mistake here. It should be 20x to the second power. Let me fix that. Because we were multiplying 4x squared with negative 5. So there it is. There are no like terms. That's our final answer. Number 6, distribute again. 2x squared times x gives us 2x to the third. 2x squared times negative 2 gives us negative 4x squared. Negative 3 times x is negative 3x. And negative 3 times negative 2 gives us positive 6. No like terms. That's your answer. 7, we have 3 different binomials, and we can only multiply 2 together at a time. So first step, I'm going to multiply the right 2 together. Got 3x times 2x gives us 6x squared. 3x times 1 is 3x. Negative 4 times 2x is negative 8x. And negative 4 times 1 gives us negative 4. Keep that in parentheses. We still need to multiply that with the x plus 2 up in front. Before we do, let's simplify the, combine like terms of 3x minus 8x. And we have x plus 2 times 6x squared minus 5x minus 4. Distribute again. Distribute the x, so 6x to the third minus 5x squared minus 4x. And then multiply all 3 by 2, so positive 12x squared minus 10x minus 8. And then lastly, combine like terms. The 6x to the third is the only x to the third. Negative 5x squared and positive 12x squared gives us, excuse me, negative 5 plus 12 is positive 7x squared. Negative 4x and negative 10x gives you negative 14x and minus 8. Number 8, again we have 3 terms, but this time I'm going to multiply first the first term with the last term because they are conjugates of each other. And when you multiply that, you end up with a difference of 2 squares. Here's what I mean. X times x gives you x squared. X times negative 7 gives you negative 7x. 7 times x gives you positive 7x. And 7 times negative 7 gives you negative 49. We still need to multiply this with the x plus 4 out in front. But as you simplify the right part of this, the negative 7x, positive 7x, they zero out, and you're just left with x plus 4 times x squared minus 49. In distributing this, x squared times x is x to the third. X squared times 4 is positive 4x squared. Negative 49 times x is negative 49x. And lastly, negative 49 times 4 is negative 196. Number 9, we have 3 terms times 3 terms. Carefully multiply this out. 3x squared times x squared is 3x to the 4th. 3x squared times 5x is 15x to the 3rd. And 3x times negative 2 gives us negative 6x squared. Then the negative 2x. Multiply negative 2x times each of the pieces. And we get negative 2x to the 3rd, negative 10x squared, and positive 4x. Lastly, multiply the 4 times all 3 terms, and you get positive 4x squared, positive 20x, and minus 8, or negative 8. Combine like terms, we have 3x to the 4th. We have a 15x cubed and a negative 2x cubed, giving us positive 13x cubed. We have a negative 6x squared, a negative 10x squared, and a positive 4x squared, giving us negative 12x squared.
we have a 4x and a 20x, giving us positive 24x and minus 8.
Number 10. We are factoring. We have 35x to the 7 minus 56x cubed. First thing you look for when you're factoring is the greatest common factor. What is the largest number or largest term you can divide both of these terms by? In this case, it would be a 7x to the third. And then what's left after you divide them by 7x to the third? When you divide 35x to the 7th, you end up with 5x to the 4th minus 56x cubed divided by 7x cubed is 8. Check to see if you can factor more. In this case, we cannot, so that's our answer. Number 11. Both terms are divisible by 5 and m to the third. When you divide them by 5m to the third, you end up with m squared n plus 2. Check to see if you can factor more. In this case, you cannot. That's our answer. Number 12, all three terms are divisible by 3. We're left with a y squared plus 8xy plus 15x squared. In this case, we have two variables. Starts with a y squared, ends with an x squared. Middle term is xy. Because the initial term after factored has a 1 in front of the y squared, we can try a shortcut here. We're looking for two numbers that multiply to 15 and add to 8. So the two numbers will be 5 and 3. So this is going to factor for us to y plus 5x times y plus 3x. And you can always check this to make sure you're right by multiplying these terms out and making sure you get what you started with. Number 13. Here we're looking to factor. There's no greatest common factor. There's no shortcut either because we start with a 6x squared and end with a 6y squared. So here we are in factoring, we are asking ourselves what two numbers multiply to 6 times 6. You multiply your first and your last number together. So multiply to 6 times 6, which is 36, and add to your middle term, which is 13. So two numbers that multiply to 36 and add to 13. So you start looking at your factors of 36. 6 times 6, well, that adds up to 12, not 13. 9 times 4, 9 plus 4 is 13. So 9 and 4 are what we're looking for. So we're going to split up that 13xy to 9xy plus 4xy. We're going to keep the first term, the 6x squared, keep the last term, the 6y squared. We're going to factor by grouping next. So look at the left half, the 6x squared plus 9xy, and ask ourselves, what can we factor just out of the left half? They're both divisible by 3 and an x. What's left is a 2x plus 3y. Then you look at the right half, the 4xy plus 6y squared. Again, ask yourself, what can I factor out of those two terms? They're a 2 and a y, and we're left with 2x plus 3y again. If you're doing this right, these two pieces in the parentheses should match, because our next step is we factor those two pieces out, and we're left with 2x plus 3y times, take what's left, the 3x here plus the 2y. And that's our answer. You can check this by multiplying that out, making sure you get what you started with. Number 14, 75x to the fourth minus 12x squared. Both numbers are divisible by 3, and we can divide out an x squared. So 3x squared to start with, and we're left with 25x squared minus 4. See if we can factor even further. The 25x squared is a perfect square, so is 4. So this is a difference of two perfect squares. When you have a difference of two perfect squares, we can factor this. Take the square root of each piece, so 5x and a 2, 5x and 2, 1 you separate with a plus sign, 1 with a minus sign, and we have the whole thing factored. Number 15, we get 27x squared minus 48y squared. Check to see what you can divide both of those terms by. They're both divisible by 3. So 3 times 9x squared minus 16y squared. Again, we have a difference of two perfect squares. So this is going to be 3 times 3x plus 4y and 3x minus 4y. The 3x comes from the square root of 9x squared. The 4y comes from the square root of 16y squared. 16. We are looking for two numbers that multiply to 6 times 6, first times the last, or 6 times negative 6. So that's negative 36. And they need to add to the middle term, which is negative 5. So what's going to make this work is a negative 9 and a positive 4. So negative 9 times positive 4 is negative 36, and they add to negative 5. We split up our middle term to negative 9x plus 4x. Keep your first and last term. And again, we're going to factor by grouping just like we did back here in number 13. Okay. So look at the left half, the 6x squared minus 9x. What can factor out of those two pieces is a 3 and an x. What's left is a 2x minus 3. You can check if I distribute that 3x to both terms, I should get 6x squared minus 9x, and I do. Now look at the right two terms, the 4x minus 6. They're both divisible by 2. And again, you're left with a 2x minus 3. Both these terms now have matching 2x minus 3, which we factor out. And we're left with their coefficients of 3x plus 2. (17). In this case, we have 4 terms. So we are going to factor by grouping. The left two terms, you can factor out an x squared. And we're left with 3x minus 5. The right two terms, we can factor out a negative 9. And we're left with 3x minus 5 again. Both parentheses match. They're both 3x minus 5, so we can factor out the 3x minus 5. And we are left with the x squared minus 9. You might be tempted to stop there, but check to see if you can factor more. That x squared minus 9 is a difference of two perfect squares. So bring down 3x minus 5 and factor further to x plus 3 times x minus 3. Again, we have 4 terms. Factor by grouping. The left 2 terms, you can factor out a 4 and an a squared. We're left with 2a minus 3. The right 2 terms, we can factor out a 3. And we're left with 2a minus 3. Both parentheses have 2a minus 3, so factor that out. And we're left with 4a squared plus 3. See if you can factor further like we did in 17. That 4a squared is a perfect square, but that 3 is not a perfect square, and we have a sum here. So this does not factor any further. That's our answer. 19. We have x to the 4th plus 3x squared minus 4. This is factorable. We're looking for 2 numbers that multiply to 1 times negative 4, which is negative 4, and adds to the middle term, which is 3, positive 3. So the 2 numbers that will make this work are 4 and negative 1. Because that x to the 4th has a 1 in front of it, we can take a shortcut and just write our answer. X squared plus 4 times x squared minus 1. Notice here I'm using x squared instead of x because we started with the next to the 4th. Can we factor further? Well, the x squared plus 4 is a sum of 2 perfect squares. You cannot factor a sum of 2 perfect squares any further. So that stays put. But the second one is a difference of 2 perfect squares. That can factor to x plus 1 times x minus 1. All right, number 20 is a difference of 2 perfect cubes. 27 is 3 cubed, x cubed is a cube, and then 1 is a perfect cube as well. 1 times 1 times 1 is still 1. And in general, if you have a difference of 2 perfect cubes, we can factor that to a minus b times a squared plus ab plus b squared. That's kind of the general form for a difference of 2 squares. And what we say is SOAP. To help us remember the signs, this is the same sign as what we started with, the minus. We have the opposite sign right here, and then the last sign is always positive. So same, opposite, always positive. That's where its SOAP comes from. So here we have, if you take the cube root of 27x cubed, we get 3x minus the cube root of 1 is 1. And then we want 3x squared would give us 9x squared. If we multiply the 3x times 1, we get 3x. And then 1 times 1 is 1. So there's our factorization. If we try to factor the quadratic part, it does not factor. We're looking for 2 numbers that multiply to 9 and add to 3. It doesn't work. So we're done with 20. Number 21, it's a sum of 2 perfect cubes. X to the 6 is x squared cubed, and 8 is 2 cubed. And so we take the cube root of each piece, we get x squared plus 2. And then square the x squared to get x to the 4th. Multiply the x squared and 2 together to get minus 2x squared. It's a minus sign because it's opposite. Remember SOAP, same, opposite, and then always positive. And then you square the 2. 2 times 2 is 4. Try to factor further, and it doesn't work. Can't find two numbers that multiply to 4 and add to -2. Number 22, we're looking for a number that divides all 32, 112, and 98. And in this case, 2 is the largest number we can divide it all by. So divide out 2, and we have 16x squared. Half of 112 is 56 xy, plus, and then half of 98 is 49 y squared. And notice the format here. We have start with a 16x squared, which is a perfect square. We end with 49y squared, which is also a perfect square. When we have that case, most likely it's gonna be able to factor to a perfect square. And we'll see that here. The 16x squared, the square root of that is 4x. The square root of 49y squared is 7. And then we get another 4x plus 7y. And if you multiply this out, it's going to work out fine. So 4x times 4x gives us the 16x squared. 7y times 7y gives us the 49y squared. And then for the middle piece, if you multiply 4x times 7, you end up with 28xy. But we get two of them. So 28 plus 28 gives us our 56. Everything's working out. As a final answer, we can write this as 2 times 4x plus 7y to the power of 2. Let me fix that y. It didn't look good. There we go. 23. What I want you to notice here is both terms have an x minus 3. And so we're going to factor out an x minus 3. When you do, what's left is going to be an x minus 3 in the first part minus an x plus 5 on the second part. If you have a hard time seeing this, just distribute it. If I go x minus 3 times x minus 3, that gives me the x minus 3 squared. And x minus 3 times the x plus 5, well, that's what's written above. Keep going here. X minus 3 times, distribute this negative, and we get x minus 3 minus x plus a negative 5. Well, x minus x is 0, so we just get a negative 3 and a negative 5. So this is x minus 3 times a negative 8. Let's try the same idea. Both have a y minus 6, so we factor out a y minus 6. We're left with a y minus 6 times an x, plus an x minus 1. So y minus 6 still out front, combine like terms, and we have y plus x, and then the negative 6 and negative 1 gives us negative 7. Number 25, we are solving, and in solving here, I'm going to first factor out a 2x, and I'm left with x to the third plus 125 equals 0. And that's a sum of two perfect cubes. So 2x times, I'm going to factor this using the SOAP that we referred to back up here, number 20 and 21. And so you take the cube root, you get x plus 5. Cube root of 125 is 5. Square the x, opposite sign, 5 times x plus, always positive, 5 squared is 25 equals 0. And then set each factor equal to 0. So 2x equals 0, x plus 5 equals 0, and x squared minus 5x plus 25 equals 0. Well, if 2x equals 0, then x is 0. If x plus 5 equals 0, then x equals negative 5. And this last part, the x squared minus 5x plus 25, you try to factor it. It does not factor. You can use the quadratic formula with this, but you end up getting two roots that are not real. And so just x equals 0 and x equals negative 5 is what we want to end with there. On 26, we can divide by 4 and get x squared equals 25 divided by 4. And then take the square root, and you end up with x equals plus or minus the square root of 25 over 4, which is plus or minus 5 over 2. That's one way to go about it. Let me show you another way. We can solve, let this equal 0 by subtracting 25 from both sides, and then factor. We have a difference of 2 squares, so 2x plus 5 times 2x minus 5 is what it factors to. Set each factor equal to 0 and solve. And we end up with 2x equals negative 5, so x is negative 5 over 2, and 2x is positive 5, so x is positive 5 over 2, which is our plus or minus 5 over 2. Number 27, I'm going to add 3x to both sides. Get 0 is 4x squared plus 3x. And then I'm going to factor an x out because they're both divisible by x. And so set each factor equal to 0, x equals 0, and 4x plus 3 equals 0. Subtract 3 and divide by 4, and you have x is negative 3 over 4. So two answers, 0 and negative 3/4. For 28 to work properly, we are going to have to change this negative 12 to a positive 12. So we want to make the right side equal to 0, so move everything over to the left-hand side. So we end up with 18x to the third plus 27x squared minus 8x minus 12 equals 0. Factor by grouping because we have 4 terms. The left two terms are divisible by 9x squared. We're left with a 2x plus 3. The right two terms are divisible by minus 4, and we're left with 2x plus 3. Notice we got a 2x plus 3 in both sets of parentheses, so factor out the 2x plus 3, and we're left with 9x squared minus 4 remaining, still equal to 0. I'm going to rewrite this, 2x plus 3 times, now that 9x squared minus 4 can factor to 3x plus 2 times 3x minus 2 because it is a difference of 2 perfect squares. So we have this factored out, 3 factors, set each factor equal to 0, and solve for x. So in the first one, we end up with 2x is negative 3, so x is negative 3 over 2. Second one, we end up with 3x is negative 2, so x is negative 2 over 3. And the third one is 3x is 2, so x is 2 over 3. Number 29, difference of two squares. Factor it. So in this case, if we're following instructions, it says to solve. There is really nothing to solve here, but there is to factor. So let's just factor this. So difference of two squares, so 2x plus 6. Take the square root of each term and put a plus sign between them, and 2x minus 6. You might be tempted to do that. If you do, that's fine, but know that you're not done, because you got to keep factoring. And so each term is divisible by 2. So factor 2 out, 2 times x plus 3, another 2 times x plus 3, sorry, x minus 3 here, and so 2 times 2 is 4, x plus 3, x minus 3. That's our final answer. Another way to do this one that might save a little time is, as said before, look for a greatest common factor. What divides 4 and 36? Well, 4 does. And you're left with x squared minus 9. And then it's the difference of two squares, x plus 3 times x minus 3. Just another way to get the same answer. Make sure you factor until you can't factor anymore. You have rectangular paper, and it's got dimensions 2x plus 3 by x minus 4. There's a square hole cut out with side length x plus 1. What's the remaining area of the paper? So that hole is cut out. So the area of the paper without the hole is 2x plus 3 times x minus 4. But then we got to subtract out the area of the square hole, so that's x plus 1 times x plus 1. We are just using the area formula for rectangle. Length times width is area. So that's an expression for our area. We can simplify that by multiplying things out. 2x times x is 2x squared. 2x times negative 4 is negative 8x. 3 times x, 3 times negative 4. Okay, I'm going to keep that in a set of parentheses, minus x times x is x squared, x times 1, 1 times x, and 1 times 1. Combine like terms, 2x squared minus 5x minus 12 minus x squared plus 2x plus 1. When you're subtracting, make sure you distribute that negative, so this becomes a positive, negative x squared, negative 2x, and a negative 1, and then combine like terms. 2x squared minus x squared is x squared. Negative 5x minus 2x is negative 7x, and negative 12 minus 1 is negative 13. So that is a simplified expression for the remaining area of the paper. Number 31. You got a rectangular prism with a volume of 6x cubed minus 28x squared minus 48x cubic centimeters. Give three variables expressions that could represent the dimensions of the box. I think we should cross out the variables. Should give three expressions that could represent the dimensions of the box. So we're going to factor. We have the volume. We want to find possible side lengths. We need to factor. So look for a greatest common factor first. All three terms are divisible by 2 and x. What's left is 3x squared minus 14x minus 24. Try to factor further because here, this gives us 2 expressions. We're looking for 3 expressions. So can we come up with 2 numbers that multiply to 3 times negative 24, which is negative 72, and we want them to add to negative 14. Do you think about this a while? You come up with negative 18 and 4. Negative 18 times 4 is negative 72, and when you add them, you get negative 14. So, continue on in factoring. We're going to leave the 3x squared alone. We're going to split up that negative 14x to negative 18x plus 4x minus 24. Factor by grouping. The first 2 terms, we can factor a 3 and an x out. We're left with x minus 6. The last 2 terms, we can factor a 4 out, and we're left with x minus 6. We could factor out an x minus 6, and we're left with a 3x plus 4. Now we have 3 different algebraic expressions that we could multiply together to get that volume, and each 3 can represent the a different dimension of that box.